That was a hell of a last week working on the EVGA terminating Nvidia relationship story. If you haven't seen it, check it out. But today, we're getting to a news recap of the week. It was mostly an exclusive. We shared that opportunity with Jay and John Petty from JPR, and there's a lot behind the scenes we can talk about with that. So this week, we'll also be talking about rumors and news alike about Intel Raptor Lake, RTX 40 series cards, and melting 12-volt power cables. So let's get started. Before that, this video is brought to you by Crucial and its DDR5 memory for Intel or AMD Ryzen CPUs. Crucial makes DDR5 kits that are deployable in Ryzen 6000 laptop systems and in Ryzen 7000 systems or Intel Alder Lake, including both budget-oriented and performance-based memory modules. If you're building a new system, click the link in the description below to learn about Crucial DDR5 memory. So first up, stories like the ones we ran this week on EVGA, they take a lot of cost, a lot of editing time, storytelling, writing, travel that we pay for entirely on our own because we don't accept paid for travel, hotels, flights, even meals beyond like fast food at McDonald's or something. So this is what allows us to do that. We've just launched our brand new medium mod mat in the AMP series. This mat is available on store.gamersnexus.net right now, and it is in stock alongside the large that we've just restocked that I have on the table under it. So the new medium mod mat will help fund stories like the ones you just watched, and it comes with a useful wiring diagram for 24-pin RGB connectors, PCIe 8-pin, and EPS 12 volts. We also have a screw tracking grid for GPU front side and back side. A new motherboard layout on the right side of the mat has the different parts of the motherboard labeled for some educational use for first-time builders. It also helps with tracking screws when you disassemble motherboards and their heat sinks and shrouds so you can know where everything goes when you're done. And we have grids scattered across the mat for screw tracking trays as you figure out what types of screws you're working with and where to put them. Our mod mats are anti-static conductive. We test them all in-house for each design, and we verify that they meet our standards for ESD safety for your components, and that means being able to protect both your table, because it's ruggedized, so it's a heavy-duty rubber that can withstand the abuses of PC building and component repair and disassembly, and it also is grounded, so we ship with a common ground point and a wrist strap. We have resistors even in the wrist straps and in the common ground points. We've designed it so that it slows the electrostatic discharge from you into the mat and eventually into ground so that you're protecting the components from a sudden high discharge that can crater things like MOSFETs on a microscopic level. So this helps us and it helps our reporting. It's also a fantastic product for you for PC building, for video card maintenance and disassembly, and it's extremely functional and has useful tools on it. It's also, if you do water cooling and you like to use a heat gun for tube bending, this is highly heat resistant and can take that no problem. Go to store.gamersnexus.net if you'd like to grab it. We sell through mod mats pretty fast. We bought a huge amount of these, the most we've ever bought, and we should have them for a little bit, but if you want one, make sure you buy it very soon because these do tend to sell pretty quickly. So, and thank you to everyone for your support over almost 5 years now. It's about 4 to 5 years of buying mod mats, and we've been refining the materials, the processes, the coding, everything throughout the whole time of that. So thanks for your support and your interest in it. We love making these because we use them every day in the lab. For the first story this week, Intel. Rumors of Intel Arc's demise have been greatly exaggerated. That's right. We called someone from Intel and talked about the rumors about Arc getting canceled, and the immediate response was, that's not true. It was a very short conversation. It was, that's not true. We're in this for the long haul. We're one of the few companies that can sink hundreds of millions of dollars into something and lose money on it or take no margin for years while we establish ourselves. So, you know, Intel's in a very unique position with Arc where its biggest weakness right now, I was actually talking with the EVGA about this related to the previous story. EVGA was sort of asking me, some of its staff about where's Intel right now with Arc, which I thought was a great sign because I hope there's interest there. Not because Intel's necessarily good, but because I think they could, if Intel sticks with this, it could be the start of another 20-year GPU partnership or something. So our view on Arc right now is drivers are an absolute mess and a quagmire, and they have to fix whatever's going on in management or staffing or whatever for the drivers. The hardware's interesting. Hardware's in a pretty strong spot. Intel is a fab or has fabs. It has capability to manufacture its own silicon, and that gives it a significant strategic advantage over AMD and Nvidia, where they have to use contract fabs. And that means Intel can cut prices lower, and it has to compete on price. So in speaking with Intel about its plans for Arc, that's kind of what they went over as well. It's just basically, yes, we can compete, we plan to compete, and we're not going away or canceling it. Those rumors were false. So I should note that wasn't an official response. It's sort of an off-the-record one. So anyway, next story. Melting 12-volt power cables from ATX 3.0 power supplies in the story this past week. So PCI-SIG is the group that governs PCIe standards. It's sort of a consortium, and it sent an email to all of its members and suppliers regarding melted 12-volt power cables called 12VHPWR. And that's that 12-pin cable. That email was technically private, but it went to so many people that we got it. And it, at this point, it serves as a reminder that, well, first of all, 12VHPWR is the new 12-pin PCIe 5.0 cable, and it's ATX 3.0 power supplies will include these most of the time. It's 12 plus 4, it's got 4 for signaling, and it's capable of handling up to 600 watts sustained on a single cable. So that's what it is. Now, the news, you may have already seen this story covered in some rumor sites, citing that the problem with the adapters converting to 8-pin PCIe power cables is what's causing the melting. But that's apparently incorrect, and it may have been based on incomplete information. Here's what the PCI-SIG email had to say. Quote, please be advised that PCI-SIG has become aware that some implementations of the 12VHPWR connectors and assemblies have demonstrated thermal variance, which could result in safety issues under certain conditions. Although PCI-SIG specifications provide necessary information for interoperability, they do not attempt to encompass all aspects of proper design, relying on numerous industry best-known methods and standard design practices. As PCI-SIG workgroups include many knowledgeable experts in the field of connector and system design, they will be looking at information available about this industry issue and assisting in any resolution to whatever extent is appropriate. And then they continue talking about timelines for due diligence, things like that. The PDF explains that Nvidia has been testing these new connectors to validate that prototype power supplies and cables can meet the specification of 55 amps continuous. During this testing, Nvidia found certain cable routing conditions led to excess heat and in some cases melting. The conditions required for the excess heat were either subjecting the cables to severe bending or a high number of connection cycles, about 40. Cables tested in these scenarios exhibited hot spots at roughly 2.5 hours and melting at 10 to 30 hours. Connectors from multiple suppliers have failed. Now, extreme bending is possible in things like ITX systems, so you need to be aware of that, even as this maybe hopefully gets resolved. Additionally, 40 connection cycles isn't that crazy. I mean, most cables, just for reference, they can endure hundreds or thousands of connection cycles, and 40 is not a lot. It sounds like a lot, but there's some room in there for failure too. So this is with a continuous 55 amps of current or 660 watts at 12 volts. This would not be a typical load condition, especially not in gaming. And Nvidia didn't observe any failures on connectors with low mating cycles without any bend. Photos provided in the PDF show some pretty gruesome melting, and it's not in the same area each time. The failures occurred on different pins depending on the direction of the cable, and this could be seriously dangerous, could lead to a fire. This document includes per-pin measurements taken during testing, as the cable was bent in various directions and severe current imbalance resulted from huge swings in resistance. We'll use this last set of test data as an example, as it's the most severe. The resistance in pins 3 and 4 measured high, especially pin 3, resulting in a measured 36.4 amps on a single pin, or 436 watts, leading to a hotspot temperature of 180 degrees Celsius. The PDF goes on to hypothesize that the bending and side loading causes the plug to improperly seat in the receptacle, perhaps deforming it. At this point, the members of the group are encouraged to do independent testing of their cables and share the results with Nvidia specifically for this one. And the test conditions here are very extreme, but the whole point of that extreme condition is that you're sort of trying to create a scenario where if it will fail, we'll be able to see it and how bad it is, so that we can try and fix this so there's not actually a fire in someone's house. Next one, leaks. More 4090 pictures here. So this was from leaker WXNod, who has been on a tear lately digging up leaked images relating to the upcoming Nvidia 40 series graphics cards expected to be announced on Tuesday. Starting with an unknown cooler that WXNod dug up, this has a dense fin stack with cutouts for board components and a large vapor chamber cold plate. Vapor chambers help to spread out heat quickly across the entire surface area, and this one looks large enough to contact memory and possibly some VRM parts near the die. Now, the next picture shows us what's under the vapor chamber. On the other side of the card is 13 heat pipes. We've never seen a cooler with this many before. More is not necessarily better. Typically they upsize. It's got a baker's dozen of heat pipes at this point. Kind of want donuts now. So the heat pipes will be bonded to the vapor chamber. Really unique combination of these two, especially with this quantity. It is a massively complex design. Really excited to see whose it is and how it works because it looks crazy. Moving on to the next leak, WXNod shows a Lenovo Legion pre-built PC with a 4-slot, 3-fan video card. The text on the card is pixelated, but just enough was left unobscured to know this is probably a 4090. Additionally, we can plainly see the 12-pin connector about 2/3 of the way down the card. We like that Lenovo left a cutout for the fins to exhaust the hot air, avoiding a trap that we used to see far too often. Lastly, WXNod shared 2 images of a Gigabyte 4090 gaming OC box. We can only gather a few details here, namely it being a 24 gigabyte card with 3 fans, utilizing a vapor chamber cooler design with a flow-through area at the end of the card. Continuing with the trend that we saw from Zotac last week in the leaks, these cards are really engineered, maybe not over-engineered, but they're engineered heavily for dealing with the massive power of 4090s, maybe drawing up to 450, 500 watts, something like that. And this is also where, once again, getting back to that Nvidia story with EVGA, that's a lot of work. That's really hard to do. And EVGA seems to seriously believe that Nvidia just disrespects all of that design work for heat sinks and coolers and PCB design that the partners do, and seems to act as if, like, why should these guys be making any money? We did the hard work making the silicon. So anyway, that's kind of just, we're going to have more behind the scenes stuff as it pops back into my head because it's a complex week of reporting. So up next, an Intel Raptor Lake existential answer. Intel's been on tour lately, hyping up and slowly releasing information for its 13th gen Raptor Lake CPUs, and now we know officially that they exist. Dr. Ian Cuttress confirmed with Intel that Raptor Lake only came into the pipeline due to Meteor Lake not being ready in time, and that development for Raptor Lake started only 2 years ago, which is shorter than most architectures. Additionally, Dr. Cuttress confirmed that the IGP and I/O haven't changed since Alder Lake, and that Intel claims a single thread performance increase of 15%. One other really interesting point here was that Intel seems to show in slides that Raptor Lake can hit 6 gigahertz without an overclock. So that's cool. And it says with overclocking, actually that's a first for x86, with overclocking, it says 8 gigahertz overclocked, and then talks about it being like basically an OC world record, but actually I think it was the Stilt, did an 8.7 gigahertz FX8370 previously, so he'd probably like to have a word about that. But either way, 13900K and KS are going to be the top of the line SKUs like usual here if there's a KS, so we'll be looking at that when it's out. Up next, an Intel Arc A380 low profile video card. And keeping up with GPU news, ASRock previously launched an A380. We showed that for US availability. It was the first one. And now this card was part of a pre-built that was reviewed by a Japanese website called IT Media, as reported on by Video Cards. And it's the first time we've seen an MSI A380 in the wild or existing in general. And it's interesting because it's a low profile. This card is a half-height 2-slot design, and the card has 2 small fans on the cooler and lacks any visible power connector. The primary inclusion for an A380 in a workstation-style PC like this is likely for ARC's AV1 encoding capabilities, which we understand to be good, but we haven't tested yet. This low-profile MSI A380 isn't available anywhere as a standalone card and only seems to be available as part of pre-builts, like the one tested by IT Media in the original Japanese source. So MSI has produced some ARC cards. Asus has made some DG1s in the past. They might do ARC cards, and we know ASRock has them. We might see more coming out with the A700 series soon. Up next, GPU-Z clamping down on Nvidia leaks. GPU-Z, the popular software utility that is used for GPU hardware reporting and logging of performance sensors. And with version 2.48, they're making a big change to modify the communication to the Tech PowerUp server instead to a GPU-Z server, which is supposed to make it easier for network administrators to isolate the ingoing and outbound communications via the network so that NVIDIA stops accidentally leaking information about its own product. Not much to talk about other than that, though. I guess don't update it if you want to keep leaking stuff accidentally, assuming it can still read it. Next one. Valve has Steam Deck repair centers now. This is actually really cool. So as the Steam Deck apparently continues to be a hit on the market, more users getting the device every week, Valve has already offered repair parts you can buy through iFixit if you want to repair your own Steam Deck if something goes wrong. Now they're expanding, though, into first-party repair centers, and that is both for in and out of warranty issues. The new repair centers will diagnose any issues with your Steam Deck, and then they let you know if the required repairs are out of warranty or in it. In the event that it is outside of warranty, Valve will quote you for the repair to be done in-house, but offer to just send it back to you if you want to handle it yourself, and then you can buy the parts from iFixit. Making parts and guides publicly available is huge for repairability, but not everyone is comfortable with working on their own electronics, obviously. So having that option is important, and the fact that Valve is treating it with the respect it deserves to allow the user to repair something or pay for a repair instead of just saying, haha, buy a new one. That's great to see. It's a big change in ethos from what we see from, for example, Apple. Up next, some case news. We've seen a lot of dual chamber cases ever since the Lian Li 11 Dynamic. Thanks, Bauer, for bringing us back to that market. And of course, its predecessor, the Corsair Air 740. And now we have another one. This one taking an approach with a different angle. That's because it's a Mars gaming case that is literally angled. And this is an MCB, is the name of the case. It is tilted. It creates a sort of showcase look, and it chamberizes the components in the system where the power supply and the solid-state drive are chambered away, hidden, and shunned from ever seeing the light of day. So if you buy an RGB power supply, this would not be the case to put it in. On the same note, though, if you buy a power supply at all and you put it in this case, don't do it like Mars did when they built their demo system. It's right up against a solid steel panel. So last we checked, not very tolerant of allowing air to pass through steel. You'd want to flip it around and let it breathe. Anyway, this thing, the main chamber, holds the motherboard, the graphics card, up to 10 fans, and a few radiators. And it looks like you'd have to be pretty careful with planning an open loop just because the thickness of the fans and radiators above and below the motherboard might block access to parts of the board or just straight up interfere and not even fit. On the same topic, if you want to populate the fan positions on the wall dividing the two chambers, you'd want to push the air into the rear chamber so as not to fight the power supply's own fan too much, which will be trying to pull air from the rear chamber and exhaust it out the back of the case. In a way, this limits the efficacy of the case's front panel fans, but one way around this situation would be to use a passively cooled power supply, which wouldn't obviously have a fan to interfere with. Despite the unorthodox layout, the construction is relatively simple, with the entire case being made out of stamped steel components, aside from the tempered glass main chamber window. There are no exterior front or top panels or dust filters, with only basic fan grills built into the fan mounts on the walls of the case. So if you want dust filtration, you're on your own to figure it out. The MCB does not come with fans. It comes in white or black for the paint options. We don't know the price at this time, but Mars Gaming appears to serve mostly Southern Europe and Mexico. We haven't worked with this company or ever reviewed any of their cases, so its products might not be easily attainable in the US, but we wanted to make mention of it for being pretty unique. And if you either want us to or don't care about this case or cases this company makes, in either situation, please leave a comment. We're going to read them and try and figure out if it's worth our time to review this. And the only reason it's worth or not worth our time these days to review a particular case is if the audience cares or doesn't care. Because if not enough people care about it, then we just skip it. We're way backed up on cases right now. Next one, solid-state drives more reliable than hard drives now, according to a report from Backblaze. Backblaze is an off-site data backup service, and like any other one, you pay them to store your data, and then they actually publish reports on the reliability of drives that they use in their data centers. So that's kind of cool. It gives them a little bit higher sample size than you might get just anecdotally. Now, it's a new one, starting with just SSD data. Backblaze published both quarterly and annualized reports, but we'll focus on the latter here. The SSDs in question were used as boot drives for Backblaze's storage servers. The important part here to look at is the AFR, or the annualized failure rate, on models with a low confidence interval. Lower is better here. As Backblaze points out, a high confidence interval isn't necessarily bad. It just means that Backblaze doesn't have enough data gathered on the model yet to call it conclusive. It's actually pretty cool to see this too, because they didn't used to publish this number, so it helps give they did publish the quantity normally of drives they were basing their data off of, but there wasn't really a good gauge for how reliable is that data outside of their use case. and now there is one. So standout SSDs from this data set would include the Dell drive listed here and the Seagate drive listed here. The Dell drive is an Enterprise M.2 drive that retails for $470, which Backblaze points out is a lot more than customers are willing to pay. The Seagate drive, however, is a consumer SATA SSD available for $45 on Amazon when it's in stock. The report goes on to compare the lifetime AFR of its SSDs to its hard drive boot drives, which the company is phasing out. The comparison was done between drives of the same age to keep it fair, and Backblaze's data through Q2 2022 shows us a few things. In the first few years of life, SSDs and hard drives follow roughly the same AFR curve, with SSDs posting slightly fewer failures throughout years 1 through 4. In year 5, the relative parity breaks, with hard drives rising to an AFR of 3.55% and SSDs actually dropping slightly to 0.92%. So for now, SSDs are trending more reliable than hard drives. Backblaze points out one important thing here, which is that SSDs might hit a much firmer wall than hard drives will, where they'll start to suddenly fail and go out of service due to media wear-out limits. Backblaze says it'll continue to collect this data and put more reports together in the future on these, especially to answer that question, as just another example of SSDs more or less supplanting hard drives in a lot of areas of storage at this point, save for price per gigabyte. This one isn't explicitly hardware news, but it's interesting news because it's about games and game prices. So the price of most large studio video games has been $60 for a long time now. Some of you may remember, at least for PC games, when it was $50 before the consoles started adding that $10 licensing fee or whatever it was, and then everyone increased their prices regardless of platform. So they've been $60, starting with, as far as we can tell, Call of Duty 2 in about 2005 for major titles and studios. Now, however, it's been slowly creeping up towards $70 for AAA titles. The last couple games I've bought have all been indie games where they're like $5 to $30. So seeing the $70 price tag for this news story, I was kind of like, whoa, where did that come from? It's pretty expensive. Ubisoft recently stated that its AAA games will now cost $70, starting with Skull and Bones, which is due to be released later this year. Although Ubisoft is the latest to make a statement like this, it isn't the first. In recent years, we've seen games like NBA 2K21, Demon's Souls, and Call of Duty Modern Warfare 2 hit $70. As more and more publishers tiptoe into that $70 slot and gradually normalize the price increase, it becomes easier for the next one to step up and follow suit. Of course, the companies want to charge more for a number of valid reasons, and also the more obvious reason, which is we would like more money now, thank you. But the more valid reasons are, or normal reasons at least, are rising development costs, of course, as they have to compete with sort of standard software companies to get developers in high demand right now, and additionally costs of everything else, but effort to produce a AAA game has increased over time. The quality standard has increased over time. It seems like a lot of companies still don't hit it, but it has increased. There's maybe an argument to be made for inflation as well. It's just that, like, if you look at it in a vacuum of purely launch price to launch price, you could justify the $10 increase. The problem is once you start to contextualize the entire rest of how video game developers make money on their games these days, like microtransactions and in-game purchases of any kind, really, because then it starts to become less clear and it just looks like they're obviously just making more money on top of money. Anyway, this could benefit indie developers over time because their prices can remain more competitive as they don't have the same scaling costs, at least not to the same degree as AAA firms. This is one of the benefits of being smaller companies, that you can be more mobile and you can do stuff for lower cost and be generally more efficient per hour of work spent. So in this case, they remain disproportionately competitive in the current market. And from the consumer's point of view, it's easy to understand why you'd want the price to stay static over time in a world where everything else has jumped significantly in price in the last 15 years. But it just seems like inevitable at this point, especially with gaming being basically the #1 pastime at this point. There's more money to be extracted and the cost is going up. So I don't know. What are you going to do, basically? But this is a great time to go check out some indie games on Steam or something where they're listed between $5 and $40 on average. Sets a sort of a precedent for them and really benefits them. That said, it's not like the AAA game companies are barely getting by. They've found ways to get the money out of you with DLC, microtransactions, and season passes all of which have handily filled the void and drained the bank account. It could be reasonable, we think, to charge $70 for a game if post-launch there's not a ton of restriction of content for other paywalls, but the level of faith in AAA developers and publishers is pretty low these days. Now, of course, getting into PC gaming or console gaming is relatively cheap as far as hobbies go. Still expensive, of course, but not as much as some others out there. So $70 versus $80 or $60. We're curious to hear where you draw the line. Is going from $60 to $70 actually a point where you're like, that's it, I can't do it? Or are you okay to get squeezed for the extra $10? Last story for this one, there's a lot of other news coming up too, but AMD Socks. That's right, they've released bikes and then killed the product. They've released CPUs, and now they're releasing socks. It's the last piece of incredibly important information this week. If you want one, you better buy it fast because they're gonna be in high demand. AMD's announced the socks that pay tribute to the classic AMD logo, the classic AMD green color, and they're available for $20. They're a little late to the game though. Intel's beaten them to the punch. Intel already has 2 heritage SKUs for socks on its own website. So we did check, by the way, Nvidia appears to not have socks at this time. Perhaps their sock manufacturing partner was dissatisfied with the service. At this point, you have many options for your footwear choices, so choose wisely. That's it for this one. Thanks for watching. As always, you can go to store.gamersnexus.net to grab our new Modmats, patreon.com/gamersnexus to help us out directly with reporting, and check out that EVGA story. It's crazy. Thanks for watching, and we'll see you all next time.